All right, so as promised, here, I wanted to give you some solutions to these Sig Fig problems. All right, so here we go. Let's practice 4.8 plus 6.8. So what we're going to do is line up the decimals here. So we're going to get 4.8 plus 6.8765. We're going to drop the 5, the 6, the 7. Of course, 8 plus 8 is 16, so we'll drop our 6, carry our 1, put in our decimal. 6 and 4 is 10, plus 1 will be 11. And so our final answer over here has to stop at the tenths of a place. So we're going to put a line right there. We're going to look at what the 7 does to the 6, and so we're going to get 11.7. All right. How about 520 plus 94.98? Here we're going to take the 520. We're going to add, we're going to line up those decimals, and even if there's not a decimal there, it's understood to be after the 0. And then 98. So that's going to be 0.98. 4, 9 and 2 is 1, carry that. That's going to be 614.98. But of course now we have to stop at the tens place. We look at what the 4 does to the 1. That's going to give us 610. That one might have got you because it's sometimes pretty tricky. 0.0045 plus 2.113. So again, we'll drop the 5. So let's go 2.113 plus 0.0045. We'll drop that 5. 4 and 3 is 7. 1.2. We'll cut this number after the 3 for the thousands place. 5 rounds the 7 up until we get 2.118. All right. I'm going to skip this one for now. I'm going to use that one towards the end here. So we'll come back to that one. 5.4 minus the 3.28. So we'll have 5.4 minus 3.28. This is an understood 0, so that's going to be a 2. To make that a 10, we stole 1 from the 4, so that's a 3 now. So that'll be a 1. And then 5 minus 3 will be 2. The 2 does nothing to the 1, so this is going to be 2.1. We had to stop at a tenths of a place because of the 4. All right, your mind is not going crazy here. I did a little pause, erase, play type of thing. That way we'd have more space again. I got 6.7 minus 0.542. Again, we're going to chop this into 6. It's going to make that one a 10. Chop that. We'll make it a 9 so that this one can be a 10. This would be an 8. Then 9 minus 4 is 5. 6 minus 5 is 1. And then we get a 6. And of course, we can't go past the tenths of a place. 5 rounds the 1 up. So this will be 6.2. All right. 500 minus 126. 500 minus 126. So this would be a 4, 7, and that'd be a 3, right? So 374. Now we have to stop at the hundreds place, which means this is now going to round up to 400. All right, and then the last problem looks pretty much like problem number 4. So we're going to go ahead and tackle problem number 4 first. Now, because we have those powers of 10, there's a couple different ways we can do this. We could expand all the numbers out, and so I'll use that method. Or what we could do is play the exponent game, and I'll show you what I mean, and we'll do that method as well. So the first thing we'll do is just expand. That's the easiest way. So this is 10 to the 2, so we'll go 1, 2. That's going to give me 600. Over here we have 10 to the 3, so we're going to go 1, 2, 3. That's going to be 3,800. Now when I subtract these, I'm going to get a negative 3,200. Now, the way it's written, this could be our answer, and we could stop right there. However, I'm going to show you how to get back into scientific notation first, and then again, we're going to deal with it in a way that where the exponents aren't completely expanded out. So in case we're working with numbers that are like powers of 32, we can't go out 32 zeros. That would be crazy. Or we can't make it infinitely small, right, if we're dividing by 10 to the 23. So when we're doing things like that, there's another way to deal with those. So first, let's just figure out how to get this back into scientific notation. So remember the decimals here. So we're going to go over 1, 2, 3 places. And so that's going to give me 3.2 times 10. Now I have this negative here. Now that negative is simply telling me the direction on the number line that it's moving. It's saying it's going negative. So we're going to carry that negative down here. Now when we moved over here, we took a big number, 3,200. Now don't mind that it's negative. It doesn't matter which direction. The magnitude was 3,200 and we turned it into 3.2, which means this has to be a positive exponent. Hopefully that made sense. We made a big number small, but we went in the wrong direction. I shouldn't call it the wrong direction, but that's the way we think about it. Because for instance, if you had to pay $3,200, that's the wrong direction for your bank account, right? Now, that's one way of handling this problem. The second way is to not completely expand things, but to get it to a common exponent. So in this case, I'm going to leave the 6.0 alone. So I'm going to take 6.0 times 10 to the 2. And what I want to do is I want to match that power of 10. So I'm only going to expand the second number to get this power of 10 to match that power of 10. So in case, excuse me, in this case then what we're going to do is move over one place. And so that's going to be 38 times 10 to the 2. Now what that's going to do is allow us to drop those exponents straight through. So whatever our answer is, it's going to be times 10 to the 2. And again, if you're only in powers of 2 and 3, it's not a big deal to just expand it all the way out. I'd even say 4 and 5 if you're really stuck. But if we're dealing with powers that are 21, 22, 23, 36, those you're not going to want to expand out. Okay, it's going to take too much time and too much space to try to figure that out. Now here we're going to get negative 32. Now I can't leave it this way. That's not correct scientific notation. So this time we're going to move the decimal point over one time, which means this is going to go up 1. And we should end up at the same answer. All right, so I did the pause and go again. That way we can work on this last problem right here. Now for this one, I'm going to use the expansion trick and just be done with it. So if you want to go back and rework this, you'll have the answer. So my advice would be to maybe try using the common exponent trick and redoing the problem and see if you can come up with the right answer that you'll now have in your hand. So we're going to expand this, which means this time we're going to go negative 2. So we're going to go 1, 2. All right, so we're going to make a big number small because it's a negative exponent. And so we're going to get 0.06. And when I write it this way, I want to keep that 0. That 0 is significant. So I'm going to write that 0 in, 060. Now for this one, I'm going to go over 3 places, 1, 2, 3. So I'm going to line up that 0 with a decimal. And then I'm going to get 0.0038. And now I'm going to do the subtraction. So this is going to be a 2, be a 6, 5, 0.0. Now we're going to cut this number right there, which means my final answer would be 0.056, but I'm going to put that back into scientific notation. So this is going to go 1, 2. So my final answer is going to be 5.6 times 10 to the negative 2. All right, so again, you have the answer now for that last one. And my recommendation would be on your slice of paper there, go ahead and give it a try. Try to work it out by making both of these either negative 2 or negative 3, doing the math, and seeing if you can arrive at the right answer. All right, so for multiplication division, this one should go a little smoother. Let me give you these answers pretty quickly here. I grab my calculator, because remember for this one, we don't have to line up decimal points, all right? We're going to take 4.5. We're going to divide that by 6.245. Now for this one, we only get 2 sig figs, so our final answer is going to be 0.72. All right, 4.5 times 6.245 to 2 sig figs is going to be 28. I'm thinking that, I don't know if you can see this on the video or not. I think the answers are right over here, to be quite honest, but we'll work them out on the slide just to make sure. 9.8764 times 0.043. And again, we only get 2 sig figs, so this is going to be 0.42. And then 3.876 divided by 1983. Now this time I get 4 sig figs. So first we're going to have a whole bunch of zeros here. Remember, those zeros are not significant. So after that we have 1955. And surely those guys over there are the answers. That's all right. 16,547 divided by 714. That'd be 3 sig figs, so 23.2. So if anything, at least I can see over here, I was getting the same answers as I've been getting all along, so that's pretty good. All right, so there are your answers for those 2 PowerPoint slides. I promised to give them to you, and there they are. So hopefully you did well. If not, again, if you can't see where your mistake was, because sometimes obviously you see me work it out and it's like, oh, okay. But if that's not the case, make sure you get a hold of me, shoot me an email, stop into one of those hours, make an appointment. There's all kinds of ways to get a hold of me. So yeah, all right then, talk to you soon.